Today's video is going to be sponsored by PCB Way. So what is a printed circuit board? Well, it's just a piece of material that has a bunch of lines in there that conduct electricity, and then you mount electronic components, right? This is how electronics have been done since like the 70s, I think. Before that, it was point to point, where you would have components and then you would connect each components. And you could see that in older equipment, sort of like in tube amplifiers from the 50s, right? You see the little components and then you just did the little wiring. I don't know much about this. I just know the basics. I'm just starting to get to kind of dabble a little bit in the circuit design, circuit board design and stuff. And, we've made one that is very, very popular, is this one, right? Which is basically not even that, it doesn't even have electronic components. This is literally just traces, right? It's just connecting battery cell holders to connectors, right? And that's about it. It's got a fuse, and this doesn't get any simpler than this, right? And so the thing is that I've been pretty successful with this. There's probably about 50,000 of these guys being printed at this point in the last 2 years, and they're being in use, right? But of course, now with the availability of batteries becoming more and more a thing, then we start to get into having to design little boards to do certain things. And that is the case for these ones right here, right? There are thousands and thousands of these scooter battery packs. These are 10S, 36 volts, 460 watt hours, so about almost half a kilowatt right here, right? And the thing is that you can buy these for about $120 a kilowatt hour. And so very easily, we can just put these on the wall and then make a DIY power wall. Or you can use like 4 or 5 and then make kind of like a portable battery, right? But the problem is that this have a proprietary design circuit, right? This is what's inside of that. And this is a BMS system. This is the thing that's supposed to keep your batteries safe and balanced. They have encoded this with some custom software, and it requires a very specialized signal. It's kind of like a digital key, right, to turn on the battery and to let the user use it, right? We have had to reverse engineer that and kind of encode a microcontroller to spit out that signal, so that then we can turn this battery and use it for our purposes, whatever we want. If you want to put it in an e-bike, you kind of need that. If you want to put it on a power wall or a solar generator, then you need to have this battery be on, right? And so here's what we're doing. Someone else, not me, right? I'm just using all this information that's available. A lot of you guys are doing quite, good work at this in deciphering all the communication between these devices and stuff. And so then now what is happening is that we have these Arduinos, where we're starting to use Arduinos to spit out that code and then use that. Right? So let me show you what is needed right now. What do we need to design so that we could make a circuit board, a device that then just turns on those batteries and then lets us use it to whatever we want. So here's the Arduino Nano that I have been programming with that special code, and then you guys have been buying it, and then you guys have been figuring out how to connect that into the thing. I made a video and I provided a simple diagram of how to do it, right? Now I want to go further into that, right? Because I, recommended for you guys to use something like this. This is a DC to DC, because we want to use the power from the batteries that we're trying to turn on to power this little circuit, right? And so there's a difference of about 40 volts in here, right? So this is 42 volts, and then this one only needs 5 volts. But this 5 volts is too high for the circuit that requires that signal on these batteries. So, there's been a discrepancy there, and we've been having to using like resistors to be able to lower that voltage. Well, it's been kind of messy, but it's been working. I think a lot of you guys have been getting these to work, but there's a better way, obviously. So now what I want to use is this one. This is an Arduino Mini Pro, and this one, it's in 3.3 volt version of this Arduino board, right? And so now what that allows us to do is spit out the right voltage so that we don't run into the danger of burning up the electronics in here, right? And so with this guy right here, now what we can do is use a more commonly available DC to DC. This one, of course, is the one that is based out of on an LM2596S. This is a very, very popular chip, and these you can find them pretty much everywhere, right? Almost every platform in China, and Amazon, and eBay, pretty much everywhere, right? And so this one will do, it will handle up to the 42 volts that these can spit out, and then you can lower it down to 3.3, which is perfect for this. Now, so here what I've done is I've made a dongle, right, with some connectors in here. And the idea behind this is just to test to make sure that these devices will work, right? That I can program this successfully, and then that I can set this correctly to lower the voltage, and then that everything works. So let's test that right now. I have a couple batteries here. One is charged, one is discharged, and we're just gonna charge the one to the other one, and then we're gonna monitor this stuff. And if it stays on, that means I have the code is doing its job, right? And so let's test that right now. Okay, so here's our little setup. This battery is connected to that dongle that I built. The DC to DC has a little light. It's kind of dim because it's being lowered all the way to 3.3 volts. And then the Arduino has also a light that turns on, and that one's fully bright because, well, that one's designed to work at 3.3 volts, right? So it seems to be working. Let me zero out this guy. This is gonna measure the current that is gonna go through here. This one right here is gonna measure the voltage. Right now it's at 38 volts. This one is at lower voltage state, so it's like 33 volts or something like that. So there's gonna be some transfer of energy just because we have a voltage differential. That's how you charge batteries, right? So let's do that. If it stays, here's how the stage is gonna work. If it stays on for more than 5 seconds, that means this battery is getting the right digital key to stay on, and that means that it's working. So let's do that. I'm gonna do this thing connected right here. Here we go, 18 amps. Right, 38 volts. It's been more than 5 seconds. It's staying on. That means it's working. So these devices are going to work. Making this, I can make a video and show you guys how to do it. I actually kind of did. But I want to make it even easier for you guys and quicker for you guys to use it. And so I am going to design a PCB, a printed circuit board, that is going to integrate this and that, right? So we can buy these pieces, and then we can quickly just stick them on this PCB, and then solder them in there, and then you're ready to go. Of course, it'll look a little bit more elegant than this. This just looks like a bunch of wires connected, right? So we could make it look a little bit better and make a dongle stuff. This is a already designed Arduino board. It has the chip, and it's got a bunch of other pieces in there that it needs to run, right? It's got a little LED, it's got a reset button, and it's got all these ports, right? Because this one has quite a bit of pins so that you can do a bunch of stuff with it. This one right here is also already engineered, and someone has designed this and put it together, right? And so both of these devices are cheap. They're like, $3 for this one, and I think this one you can get it for somewhere around the same $3 or $4. So you're looking at less than $10. Then I can make a board. That's what I'm gonna do here. Design a board that you can then solder both of those in here, right? We can do that in-house, and then we can design an input and an output, and then the whole thing will be neat and stuff, right? Of course, this is not the only way to do this. You could also make a printed circuit board and then, just integrate all of these devices that you need in there in a single board. Sort of like this one here. Someone else did this. So a gentleman did this and sent it to me. And as you can see, well, it's a lot smaller, right? Because he only used the parts and the components that you needed. He used a different Atmel chip in here It's one that is probably slower. It doesn't have as many ports or whatever because it doesn't need it. For the little simple task that we need this thing to do, you don't need this. This is almost like overkill, right? It's got a ton of like inputs and outputs, digital and analogs and all this other stuff, right? And so there are different ways to do that. I don't feel capable of doing this. I've never done this. I've never designed a board and then have it populated with well, this is surface mount components. These are so tiny that you basically need like a machine to do it, right? And so that means you'd have to pay someone in China to do it. Now, I want to work my way into having the ability to do this, but I'm not there yet. And so I am going to work with what I am capable of doing, and I am capable of now designing a PCB board using these two boards in here, you know, and then do that. And by the way, I just learned this, like literally like last week. I learned to, you know, draw and design a circuit board. So I'm using newly acquired skills to do this thing, and I'm gonna show you how I'm gonna do it. You'll probably laugh at me and probably correct a lot of the stuff that I'm probably gonna do wrong, right? But nevertheless, this is how you learn. You just do stuff, and I've never ran away from learning new tricks. So let's get started. All right, so because it took me more than an hour to do this, I'm gonna just fast forward, right? And so I'm gonna show you here. Here, you're gonna use an app called EasyEDA. You can download, that's free, and it's easy to use, open source kind of thing, right? So the way it works, you have to get the parts from a library, and luckily these two parts are available. And so then what I'm doing here, I'm just taking off all the things that I don't need for my thing, right? And then I'm adjusting the size of the board here, right? And then I'm running traces, right? These are those little lines that will carry the signal. And then because I'm gonna have two main ones that are gonna be carrying all the power, then the signal ones should be kind of small. And then I think eventually I'm gonna figure that out, that I need to move them to the center, because I'm kind of to the side there. So I need to put them to the center so that then they take the least amount of space, right? And I wanna run two different sides, or both sides of this board, with copper. And I don't know if I need to do a 2-ounce copper. There's two different thicknesses of this copper. And since this is only going to be designed to run with only one of these battery packs, then maybe not, because I only require 25 amps, right? So here are vias or bias, I guess. I don't know what those are called, but those are just connecting one side of the board to the other. Then I'm putting the text in there. It's pretty simple, really. You just gotta play with it, and it's pretty intuitive. You just look around with the tools, and then you do the thing, and then you put the this is only one way to design boards. There's different ways, but it kind of works. So just like that, I am done with this board, and it's ready to be printed out. Okay, to print this board, you have to head over to PCBWay. You make an account, you log in, then you upload your Gerber file, right? And then after that, it has to be reviewed. So they take, I don't know, like a few minutes, sometimes a couple hours, and then they review it, they approve it. And then after that, you will be able to order it. And it usually takes a few days for them to print it out, and then it's on its way to you. All right, they've arrived. Let's look at our boards here. Here we go. They come in this little package. It's up. Pretty nice. Let's test it. I guess I gotta populate one of these. Okay, so that was very easy to connect these cables in here and to put the little, you see what I'm using here? Those little things that come with Arduinos. I don't know what these things are called, but I just used 4 of those to attach the DC to DC. Now, before we put the Arduino, we have to set this to spit out 3.3 volts, right? It's gonna go from 42 volts from here, and then it's gonna convert that into 3.3 to power the Arduino. So before we put that and connect it in there, we gotta do that. And here I'm gonna use one of the batteries that this is designed to power, right? Okay, so we're gonna use a screwdriver and a multimeter. You put that on the output here. So then you start turning this little pot here. Oh, 28, no. We wanna go down. All right, 3.36. There we go, that's good enough. Now, let's program the Arduino. Okay, so I have connected the Arduino here with an FTDA cable, right? And then I've loaded up the Blink. I like to use the Blink sketch, right? And then you upload it here. Okay, so here we go. You see how it's blinking? Okay, so that means that now we're communicating with the thing and we're able to upload the sketch. Okay, so now you skip that one, and now we're gonna do the one that sends out the serial bits or whatever to wake up those, that it's like the digital key to wake up those batteries, right? I made a whole video on how to do it and how this works. I'll link it in here, but here we go. I'm gonna upload it. There's a few lights blinking there, and then the little light that is blinking will stop. If this Arduino had a light for the TX, and it would be blinking every 5 seconds, but this one doesn't have. This is a very basic one, and so it doesn't. But now I know that it is programmed in there because the blinking thing was able to load up, and this one loaded up. It didn't show any errors, so we should be good. Now this should be spitting out the signal that we want. Now we can put it on the dongle. And there it is. Now the last thing to do would be to put like some clear shrink tube in here, but I don't have any. So if you're building this, shrink the whole thing up, should be fine. Let's plug it in and see what it does. There we go. See, more than 5 seconds, it hasn't turned off. That means our little dongle is working. And so that is what you need to do. All right, so what can you use this little dongle here? Well, this is kind of like a standalone dongle for, like, if you want to use this scooter batteries for your own DIY scooter, or for an e-bike, or for a skateboard, or anything else that you want to do and you need a single cell or maybe just a couple of these cells of battery packs, right? It has this little connector so that it connects right into the battery, so you don't have to modify that connector. That is kind of specialized. I don't know, it's kind of weird. I never seen it before. And then it just makes it into a very universal XT60. So how can you get this? Well, I'm gonna upload this as a project to PCBWay. They have a thing where you can then go and download the file, order the board, and then order all these parts. I'll provide links for all this stuff. And of course, I'm also going to offer these on Jack 35 already made, just in case that you're one of those that doesn't want to bother with making one of these yourself, right? You could just buy this together. Of course, it's gonna be more expensive than just buying all the parts and doing it yourself. But if that's the thing, if you don't want to solder and figure out how to download a file or order a PCB, printed circuit board or whatever, then that's also available. So thank you for watching this video. Thank you for PCBWay for sponsoring this video. We'll see you guys on the next one.